Hi everyone, in this video we will explore how we can use multiple representations in the social network section of part 1. During my student teaching, I used an organizational tool called a VANG chart, and the VANG stands for Verbal, Algebraic, Numerical, and Graphical, and it was a way for students to organize all multiple representations of different types of functions. So for example, linear or exponential or rational, or any of the other types of parent functions. My goal for this video is to model how we can use a similar organizational pattern to support students in seeing how linear change does not keep up with exponential growth, and how the different chances of people being convinced by the misinformation in part 1 can lead to different patterns in our graphs and in general the outcome of the experiment. The verbal portion is what I would label the experiment as, where the mentors or the slides explain the situation to the students. Some students are okay with verbal instruction, and what I mean by that is if you give them a situation, they will be able to imagine it in their head and process it and maybe start to notice some patterns. However, if students are like me, I really like writing things down or drawing little pictures in addition to the verbal to kind of help me get a grasp on the situation, and that process helps me come up with the patterns. This is where I believe a tree diagram is appropriate because we can use the verbal explanation or the experiment to draw out what's happening. Now, some suggestions for our tree diagrams is I would say make each of the nodes or the little circles in our tree diagram the same size, because we want to make sure that students process each node as one person, and one person should be equal in value regardless of where we are in the tree. I would also recommend keeping the nodes that are in the same time period. So for example, all the new nodes in the same minute, have them all be horizontal or lined up basically in a horizontal line. This is just to make our organization a bit better and just make it as easy for students to process the tree diagram as possible. Now, once our tree diagram is nice and organized, we can go ahead and transition into a table. You can ask the students or point out how many people are infected at minute 0, and the answer would be 1. And then you can ask them how many people were infected, or how many new people were infected after 1 minute, and then they would say 2. After 2 minutes, it's 4. After 3 minutes, it's 8. I would like to point out that these numbers are not the total number of people infected, but by separating them into new people that are infected, we are able to better see the pattern, and that pattern would be multiplication. So that would be the algebraic portion of the VANG chart, where students see that the number of new people infected is doubled each time. Here would be a good time to bring up linear change, and this is just how I interpreted the tree diagram for linear change, where each time we are adding 2 instead of multiplying by 2, but we start with the same amount of infected people. Now that we have identified the pattern and we have our tree diagram, we can go ahead and make a table like so, where we simply have the time or in minutes on the left-hand side and the number of new people infected on the right-hand side. Then there's that pattern that I mentioned before. And the great thing about making this in a table is that now we can skip some numbers and let go, for example, from 3 all the way to 10 without having to draw all of those nodes and those connectors. And once we have our table complete, then we can just go ahead and plot those points on an XY coordinate plane, and students will be able to see that the growth or the number of new people infected grows exponentially. And again, if they want to get the total amount of people that are infected, they will just have to add all of the previous entries together. So for example, how many people have been exposed at minute 2? You would do 1, the original person, plus 2 from minute 1, plus 4 people from minute 2. So that would be 7 people exposed. And to reinforce the learning, you can also repeat this process, but with a linear change instead. Once again, the great thing about this organizational tool is that you can use it when the problems get more complicated, like in the latter parts of this section where we incorporate probability, and you can modify your tree diagram by only coloring in certain nodes from the result of flipping the coin. I hope that you find this organizational tool handy and helpful during the meeting. If you have any questions, feel free to reach out. Thank you so much for watching. Bye.